Hi and welcome to a project presentation. We would like to thank the Emertxe Information Technologies for providing us this opportunity. Myself Bhavna and my two other project mates Bibi Mariam Mullah and Mohammad Tasneem A are here to present our internship project documentation. Let us first go through the overview of the internship. Firstly, there was a kickoff meeting held in two parts and a technical orientation program, but the technical head Mubin Jaisar gave us a clear idea of what we are going to do in the internship. The emergency management has also provided us some useful C programming and microcontroller resources with which we understood and executed all the template codes. Coming to the core internship details, in the week 1 we were taught the important C programming concepts like functions, pointers, operators and preprocessor directives, which are very useful for us in writing the code for this project. In week 2 we were introduced to the project requirement, design, embedded systems and its programming. In the consecutive weeks we were taken deep into the project details like building the peripherals, programming the peripherals, and integrating all the peripherals required for the microwave oven simulation and testing them. In this project, the embedded system we are going to develop is the microwave oven. So, what actually is a microwave oven? It is a cooking device that can cook or reheat food much faster than a conventional oven. Then, why only a microwave oven in this internship? So this is an embedded internship. Here we are to build an embedded system hands-on. So we found that microwave oven is the best model for understanding how an embedded system works. As beginners, we found this very interesting and we contributed our efforts in finishing this project. Abstract of our project. Our objective is to implement all the modes and functionality of a microwave oven on PIC16 F877A board using MPLAB XIDE and XC8 compiler, testing it on the PICSimLab software. And the key features of this system are 4 different cooking modes with individual countdown timers and manually set temperature, and it has also got the generic code and easy to implement kind of features. Contents of this presentation are as follows. We will discuss the project development phases, about embedded systems and its components, microwave oven components, overview of the code and simulation, and we will also explain the challenges faced. The first content is the project development phases. So this project is developed based on the waterfall model in the software development life cycle. These phases are 5. First is the requirement analysis, second is design, third is implementation, fourth is testing, and fifth is evolution. Next, coming to the definition of embedded systems. The exact definition of embedded systems is any combination of hardware and software which is intended to do a specific task is called an embedded system. Examples of embedded system are microwave oven, traffic lights, washing machine, TV, cameras, refrigerators, etc. Let us discuss the categories of embedded system in detail. First comes the standalone system. Again, the standalone system is classified into two. First one is the slave system and the next one is the independent system. In the slave system, we can say that the system is non-cognitive. It cannot take action on its own, but whereas an independent system can take action on its own. Driverless car is an example of independent system. Next comes the real-time system. The real-time system is like a time-bound system which takes action only on a specified time, and it is categorized into hard real-time, firm real-time, soft real-time systems. Airbag system is the best example for real-time system. And next comes the network system. Network system is like a system which is connected to a network. Basically, we can say that these are the components of Internet of Things. Example for the network system is home automation system. And next comes the mobile network system. Mobile systems are those which are movable. Example, robots. And here are the requirements for embedded system. These give us a clear idea of selecting a microcontroller or some reliable components which build up a effective embedded system. And here are also the challenges which are faced while building the embedded system. This block diagram explains the components of embedded system. CPU is the heart of embedded system, and whereas all these blue boxes are like the hardware components, and software block is where we need to write the code and convert this code into some hex file, and we need to load that into the CPU. Here are some important terms about the embedded system. We need to know about host, target, cross compiler. Host is nothing but a system which is used to develop the target, and target is nothing but a system which is being developed for a specific application. Whereas a cross compiler is an application used to generate code for another architecture being in another architecture. Example for cross compiler here used is XE8 compiler, and it is supported by MPLAB XIDE. The architecture of any microcontroller is something most important in understanding the peripherals. Let us have an overview of PIC16F877A microcontroller architecture. Here LEDs, buzzer, digital keypad, matrix keypad, CLCD and other components are used in our project. In the coming slides, let us discuss them in detail. Here are the components required for our microwave oven simulation. So a PIC microcontroller is used, and a CLCD, a buzzer, a matrix keypad, and the software used for this project is MPLAB XIDE for building the code and PICSimLab software for simulation. Let's discuss these components in detail. Starting with the PIC16F877A microcontroller, it is used in our project because it can do many tasks because of its large enough programming memory. And its operating frequency is 20 MHz, flash program memory is 8K, and data memory is 368 bytes, and it also has 5 input-output ports named A, B, C, D, E. It also has 15 hardware and software interrupts, and 2 capture PWM models, and USART and PSP for serial and parallel communication. This microcontroller is especially used in sensor and control projects. The next component is a CLCD. This liquid crystal display is used to display all the ASCII characters, and it has 2 communication modes. First is the 8-bit mode and second is the 4-bit mode. Matrix keypad is another component in which tactile switches are used. Here there are 4 rows and 3 columns of tactile switches, in which all the columns are connected to the port B and all the rows are connected to the port D. Next comes the MPLAB XIDE. MPLAB XIDE is a integrated development environment where the system code is written, and it supports the XE8 compiler to compile the code and generate hex files for PIC controllers by compiling the C code. The PICSimLab here is a simulation lab where the output of the written code is virtually observed. This plays an important role for testing the outlook of the embedded system. Let us have an overview of the code. Let us see the MPLAB XID overview. So this is the interface of the MPLAB XID. So for creating a project, we need to click on new project, and embedded microchip embedded. And next, and in the all families we need to select the mid-range 8-bit MCUs, and in the device, as we are using the PIC 16F8778, we need to select this. And next, and here we are using the XE8 compiler, we need to select this. And next, project name, let us consider for now it as a project demo project. Finish. So now it is creating a project demo name project folder. So this is the project demo folder. So in this way you can create a project. For opening the existing project, we need to click on this open project icon, and here I have already used this microwave simulator. You need to check the location of your file and upload it accordingly. So I opened my microwave oven simulator project. Let us look at the main function. So this is the code that we have written for the microwave oven simulation. So let us build this code. Firstly, let us close this project demo so that we can build this one. Let us build this main.c function. So here we can see that the build is successful. And next we need to open the PicSimLab. Here we are using the PicGenius board. In this microcontroller we need to select PIC 16F8778 and the board is PicGenius board. So in this file section we need to load the hex file. So loading hex file in the sense microwave oven simulator. So this is the final output of my project. So let us discuss all the modes and everything. Firstly, the microwave, micro mode, grill mode, convection mode, start mode. Let us click on the micro mode. So it's showing the power equals to 900 watts and there is a set timer. So let us enter some, for time being let us enter 7 seconds. Hash symbol for enter. So there is a buzzer sound. Next we'll try for the grill mode. Enter 2 for the grill mode and similarly let us enter 5 seconds and hash. Let us do this pause and again start. Next let us check the convection mode. Entering key number 3. Set temperature. Let us firstly check for the temperature which is above 250 degrees. And let us set the temperature for below 250 degrees. Here this is nothing but the operating frequency of the PIC controller board, and this is the CLCD display. Now we are using 16x4 display, and this fan represents the working of the microwave oven. Here is a buzzer, and this is the matrix keypad. So it is taking 180 seconds for preheating. It may be any temperature from 0 to 250 degrees. It takes 180 seconds for preheating. So if we want to stop it in the middle, we can use this reset button. It changes its state to 0 again. And let us see for the start. So automatically it will be giving some 30 seconds of time, set time, and it displays the countdown. After this, a buzzer can be heard. And that's about the project overview and the simulation overview. Let us discuss the challenges faced. While testing and checking all processes are working correctly or not, we got to know some bugs were present in the system. So we fixed the bugs by updating or adding some lines in the code. In the initial days of coding, we faced some problem in the level triggering and edge triggering part. We took each other's help and resolved the problem. And in the set time function during the micro mode, the blinking part took us so much time to code, and after ma'am explained the concept, it was clear for us. And next, the acknowledgement for this internship and project is we learned the embedded C concepts and core concept of how to build an embedded system. In this internship, we learned about the PIC 16 F877A microcontroller, which is the main component in building this project. We also learned about the peripherals of the microcontroller like LCD, matrix keypad, timers and buzzer that are used in this project. Our project mentor made it easy for us to understand all the concepts. We would like to extend our gratitude to each and everyone who supported us in finishing the project, especially our mentor Rajni ma'am. This our workshop organized by Jaikumar sir were also very informative, and we had many fun-filled learning experiences. Great learning has happened for us this year, which made our 2021 special with Emertxe Internship. So we would like to build more projects on PIC microcontroller and gain more knowledge in the embedded systems and increase our skill set standards. Thank you.